Of all the dimensions known to man, there is only one in existence that you can enter, where three-dimensional printing meets the bone zone. This is my Ender 3 V2, which is a very affordable 3D printer priced at only $262 from the official Creality store. The Ender 3 V2 is becoming more popular as it is a nice upgrade, having better electronics and features over the others in the Creality Ender series, like the cheaper Ender 3 or Ender 3 Pro. Whether you plan to buy one or have just bought one, hopefully this video guide will successfully show how to build an Ender 3 V2 3D printer in great detail. First, let me show you what this printer can do when built correctly, as I hope it is the same outcome for you. There are other printer options, but personally I have used both the Ender 3 Pro and Ender 3 V2 and felt they work great for me. I definitely get what I want from them, although they do need some calibrations, maintenance, and some love to keep them in good condition. I find it to be a really fun hobby and is definitely worth it. I'll get right into the build now, so first let's get the box out, with mine having some minor damage, although all parts were completely fine. I will open the box and take out all the parts, making sure I have what I need to build. Part 1. The unbox. Opening the box, there's a nice presentation with the Creality info and manual baggie, and just grabbing parts, there is the X-axis and extruder motor kit, the display kit, gantry and X-axis profiles, material rack and a pipe with nut or the spool holder, hot end and nozzle kit attached to the printer base. Moving to the next layer, the Z-axis motor, baggie of accessory tools, power cable and Z-axis passive block, baggie of more accessory tools and parts, X-axis tensioner baggie, a metal blade or scraper, and an empty bag, and finally the Z-axis left and right profiles with T-type screw rod fit inside. And that's all from the box. These should be all of the parts, so hopefully you have all of them and enough space to hold it all. Part 2. The bags. Opening this first, the Creality bag has a qualified certificate, thank you note, Creality Cloud invitation card, warranty card, and finally the user manual for building and starting a print. The user manual has a lot of information, but this video will be a visual guide and a reference for showing each step in detail. For the next, the baggie of accessory tools comes with side cutter pliers in a little box, 5 zip ties, another small bag with a double-sided wrench for certain nuts and bolts, and a small wrench for the nozzle, flathead screwdriver, and 5 sizes of Allen or hex keys, referring to the biggest as the 5th and the smallest as the 1st, and lastly a pointy needle for nozzle jams. I opened the last bag when building so as not to lose screws or other small parts from it. To show off the build process, I quickly go through the user manual. These first pages are just some notes, and the next shows the full machine with its equipment parameters. It next shows all the parts that should come from the box, which I do have all of. It starts the build with step 1, installation of Z-axis limit switch kit and Z-axis profiles. Step 2, install Z-axis motor kit and T-type screw. Step 3, install pneumatic joint, XE-axis kit, and synchronous belt. Step 4, install nozzle kit, Z-axis passive block. Step 5, install X-axis tensioner. Step 6, install the Z-axis moving kit and adjust the tightness of X-axis and Y-axis tensioners. Step 7, install the gantry profile, display kit. Step 8, install material rack, gantry cover, and indication knob. Step 9, wire connection. Step 10, bed leveling. Step 11, shows a level bed with the nozzle. Step 12, preheat options. Step 13, load filament. And step 14, start printing. The next page shows the motherboard connections for you to double check. And these last pages show troubleshooting suggestions. With enough space and everything needed to build, I start to build. Part 3, the start. With the tools nearby for easy access, start out with the whole printer base and move the extruder safely away, not breaking the attached wires or tubing. These side cutters or needles are not needed yet and can actually be put away in the little storage drawer for now. Before starting any electrical build, the most important step is to make sure the voltage is correct, so things don't explode from over voltage or not work from under voltage. Flip around the machine and make sure the voltage is set correctly to your country's correct voltage. I'm in the US, so it's 115 volts for me. Please double check your correct voltage and set it correctly. Also, the power switch is back here, so make sure the machine is unplugged and turned off for now. With this first precaution taken care of, flip the base back around. Now is the easiest time to tighten and stabilize the bed, and mine is quite wobbly. Grab the double-sided wrench, then flip the printer on its side and locate the two eccentric nuts, usually under the right side of the bed. While holding the bed still, slowly tighten down the two eccentric nuts and then check if the bed rolls smoothly. Make sure to not over tighten as it won't move, or there will be a lot of stress on the wheels, wearing them down very fast. The Y-axis belt can also be tightened up front with the blue knob to make sure the bed is fastened with no slack. My belt was visually tight enough. Now my bed is secure, but is wearing down the rubber, which I'll just fix later myself. It took me a couple of tries to get it just right, so make sure to tighten in increments until the bed is both stable and can roll quite freely. Additionally, if you want to check the other electronics now, you can do so, otherwise I show it later when it can be stable on its side. Part 4. The Z-axis. Grab the bigger profiles and unwrap them. The T-type screw rod will be inside one of them, so carefully take it out and set it aside for now with the protective cover on as the rod is greased up. Grab the last baggie to open. I'll spread some of these parts on my workspace. It contains a small amount of filament, which can be put aside for now, the extruder knob, X-axis belt, Z-limit switch stopper, mini SD card and USB reader, profile and covers, bag with nozzles, pneumatic joints, and plastic claws, and last, all the nuts and bolts including M5x45 and M5x25 screws, M4x16 and M5x8 screws, M4x18 screws, and M5T nuts. For the Z-axis, grab the long M5x45 screws, and note there are two different profiles. This one is for the left side that has two holes lined up at the bottom portion like this. This one is for the right side that has two holes lined up vertically like this. Both these profiles have two holes in the top and bottom that line up with the base profiles. The profiles will stand upright like this. So grab the 5th size hex key and two M5x45 screws and flip the machine on its side. Then start by hand tightening one of them to align the profiles and tighten with enough give so later can move and align all the profiles before fully screwing everything in place. Do the same thing for the other side, making sure the left is on the left side and the right is on the right side of the base. With the profiles in place, grab the Z-limit switch, which will be put on the left side profile, and use the 3rd size hex key. There are two screws with nuts that slide snug into the profile slots, so when screwing, the nuts should turn and fit snug. Make sure the switch is pointing up, and align the Z-limit switch with this nub, which should end up level with the bed. This ensures the machine will hit the switch stop before going past the limit and potentially damaging the bed. It should install nice and easy. Here's a closer look. With the profile set up, before continuing on, now is a good time to check the wiring for safety, and to also check for the version of the motherboard. I highly suggest taking the time to do this. Part 5. Electronics. With the printer upright, there is a small screw to remove on the top cover, which is underneath the bed area here, and then setting the printer on its stable side, remove the 3 screws on the bottom of the casing to prop open the electronics, keeping track of screw replacement, and be careful as the fan is attached to the metal cover. And mine decided to venture the earth, and so the fan got unplugged. Quickly check all the connections are snug and look for anything suspicious. Take note of the motherboard version now for any future needs. A note of caution is that some of this wiring is soldered rather than crimped and may be a fire hazard. So far I have had no issues myself after months of use. If everything seems wired correctly, put the cover on and screw it back into place. To check the power supply unit, start with cutting off the zip tie under here with the side cutters. Continue with grabbing a number 2 Phillips head screwdriver and start with unscrewing these 4 screws around the cover. After unscrewing these 4, grab the 2nd size hex key to unscrew this one top left, and grab the 3rd size hex key for these 2 screws on the right side to fully take off the cover. First, look to see if it's a Meanwhile power supply, which mine is indeed. Again, you may check and change out any soldered wires to crimped wires, otherwise I leave my power supply the way it is, as I have had no issues. One thing I want to try is cutting out a small section so this area top here can get better circulation. For now, I put this cover back on with the right screws in place, and then finish off screwing back these four, securing it back to the base. Then reattach and zip tie the wires back under here. Now to continue with building the Z-axis motor and T-type screw rod. This motor screws behind the same left profile and needs two M4x18 screws. The T-type screw rod is greased up, so it can get messy. This screw rod should insert into the hole of this connector piece, which there are two screws that tighten or loosen both ends if it does not fit. The bottom screw is to attach the connecting piece to the motor itself, so make sure that it is snug and secure, and aligned right, leaving enough room to hold the screw rod correctly. The top screw loosens and tightens the portion where the screw rod will be inserted, so loosen it up first so the rod can slide on top as so. With the rod still covered, grab the top and let the rod fall into the piece, leaving the cover on to not get the grease everywhere. Tighten the top screw until it fits real nice and is snug and the rod does not wiggle. Do not over tighten this piece. Next is to screw the motor into the back of the left extrusion, so working on the back of the machine now, grab the two M4x18 screws along with the third sized hex key. The motor should have this plastic piece, which is screwed into the profile. Align and screw the motor in with the two screws, and leave it loose so the motor itself can slightly wiggle. This will help later when we align the rod with the rest of the assembly. Here's a closer look. Part 6. The XE Axis Kit. You may need more space to assemble this part. Also, I will install the pneumatic joint or Bowden coupling later. Grab the X-axis and extruder kit and the other smaller profiles. These are two different profiles again. The one with only 4 holes, 2 on the left and 2 on the right side, are for the top part of the gantry. The other profile with more holes, having one all the way down on one end, is for the X-axis assembly, so set the other profile aside for now. With the profile and XE kit, grab two M4x16 screws that are needed as well, which will use the third sized hex key. The front of the extruder kit piece has the QR code and X-axis switch, and has 2 holes and the end nut for the wheel. Looking at the profile, there is a hole part with a cutout which will cover that nut and align with the holes. The screws will be screwed going towards you like this into the profile. There are holes on the other side of the extrusion kit piece where the Allen key fits to tighten the screws easier. Align the profile to the holes and screw it in place. I used the last profile to prop up these pieces to help me screw it in better. With that screwed in nice and straight, continue with grabbing the belt and belt tensioner, the Z-axis passive block, and the base that was just assembled with the attached hot end and nozzle kit. With the hot end and nozzle kit connected to the base, be careful to not scratch the glass bed, so maybe use a towel or another surface to assemble the step. First, I put the belt through and around the X-axis motor, and make sure it is not twisted and fits nicely into these grooves. I let it hang off to the side so the hot end and nozzle kit can slide on. The profile assembly should fit through the 3 wheel bearings on the back of the nozzle kit so that it slides on the rail. Make sure to align it correctly with the fan cover and QR code on the same side and with the nozzle pointing down. When aligned correctly, the one end of the belt can be tucked snug into the slot on the other side of the kit. Next is to attach the Z-axis passive block, or the triangular part, to the other end of the profile. The bearing wheels face backwards and get screwed in from the back with another M4x16 screw. Then empty the bag with the belt and belt tensioner. To attach the belt tensioner, first make sure to find out how the bearing with threads fits into the little cover. Note the short top face and one side having a large hole, which will be the back side of this cover, so the front only has 1 screw hole. On the bearing part, there's a flat side, and there are little groove cuts that should be on the top face, allowing it to slide into the cover and correctly align. With the orientation figured out, take the other end of the belt and pull it through the bearing to pull it over the profile and attach this end onto the other slot of the nozzle kit. Then slide the tensioner cover over to align the back and screw another one of the M4x16 to secure the cover through the back of the triangular plate. Now on the front side, use the countersunk M4x14 screw to screw the cover in place. With the tensioner all in place, grab the blue thumb knob and screw it onto the end of the belt tensioner and tighten the belt till it's snug. Do not over tighten this. Slide the hot end around and make sure it slides smoothly across, back and forth, all the way to the left side switch and all the way to the right. It should stop close to the triangular plate. If the kit seems loose, there is an eccentric nut on one of the wheel bearings, so tighten this nut here until the kit is secure on the profile. Here is a closer look at part 6. Part 7. Install the X-axis kit. You may have already tensioned the belts, so now with the X-axis assembled correctly and screwed in, it's time to install it to the base. The bearing wheels should fit comfortably over both vertical profiles. Along with the wheels, the rod should line up and fit into the threaded hole in the extruder, or this golden part here. Try to line it all up, making sure all the wheels and the rod will both fit and move up and down very smoothly. Do not force any of this, as you may potentially cause damage or wear. There are 2 screws to loosen the gold threaded hole and align everything up. Loosen up the gold threaded hole until everything aligns better, allowing complete smooth movements up and down. Using your hand, turn the bottom of the Z-axis motor, not the greased up rod, and it should move up and down nicely. It is important to not wear out the long T-type screw rod or Z motor. If it is aligned correctly, it is time to retighten the Z motor to the profile. Make sure everything still moves smoothly up and down. Keep loosening or tightening as needed until the Z-axis motor is secure and the gold threaded hole is aligned correctly for smooth movement. Part 8. Finish the gantry. To finish up the gantry, it's time to grab the last profile with 4 holes to screw onto the top of the vertical profiles. Also grab 4 M5x25 screws. Check the profile to see the grooves cut for the top face where the screws will insert into. Align all the holes and hand tighten those top screws first. Then go around, fully retighten the bottom screws under the base, and then finish fully tightening the top screws, leaving everything aligned and really secure and stable. Again, go around and double check that everything is tight and moves smoothly with absolutely no hiccups. After the motor is stable, go back up top and slowly tighten the gold thread until everything works extremely smoothly. Again, do not over tighten anything. At this point, the Z-axis passive block also has an eccentric nut that can be tightened or loosened for the wheels to hug the profile for better motion. Part 9. The miscellaneous. Grab the metal material rack, the pipe, and 2 M5x8 screws, and 2 M5T nuts. The end of the pipe kind of screws in like this, then take the screws and nuts and hand tighten them in the 2 small holes in the metal rack. Now put the pipe through the metal rack and screw it in with it on the inside of the indented portion. The nuts should slide into the slot of the top profile piece and then tighten up the screws with the 4th sized Allen key. I put mine to the left, closer to the extruder motor where the filament will curve nice and line up to be extruded. It should fit nice and snug after tightening the screws. If not, try to use the Allen key or other small object to kind of align the nuts in the slot for a snug fit. Now throw the sample filament on there. Grab the plastic display holder and the display itself. The display can be popped separate from the holder, with the holder having these 3 screws and nuts that will slide into the profile V-slots. So remove the bottom profile cover and slide the nuts into the slots and then tighten them with the 3rd hex key for a snug fit. On the back of the display, there is a connector with a small notch that lines up with the rainbow connection coming from the bottom. So align and connect it into the back of the display. This can only go in one way, so do not force it. It should connect nicely. Now the LCD display can be popped into the holder and snapped into place. Time to put the finishing touches for the build. Grab the small profile covers and slap those on the ends of the top profile. Grab the baggie with the pneumatic joint or Bowden coupling and screw it into the threaded hole by the extruder motor and tighten it with the double-sided wrench. This is where the filament will feed out of through the PTFE tubing connected to the hot end and nozzle. This tubing should have a completely flat cut before being fit into this coupling. Push the tubing as far into the coupling as possible and use the little blue plastic claw, as it should snap around and keep the tubing nice and snug in the coupling. To make sure it's really snug in there, give a small tug and the tube should not pull out at all. And now grab the blue knob, which has a hole and flat groove that should fit nicely over the teeth gear, aligning that flat part. Last finishing touch is to hook up all the wires and connect them correctly to all the motors. Make sure the wire connections align with the little nubs for correct fitting. At the base by the Z limit switch, there should be a thinner wire hanging out that should have the letter Z on it. This connects to the Z limit switch like this, making sure without much force it goes in correctly. The thicker wire with the Z on it will connect into the back of the Z motor like this. The other cables hanging out from the hot end will connect to the extruder and X-axis motor and X-axis limit switch. One should be labeled E for extruder and the other two X for X-axis motor and X-axis limit switch. Connect the thinner X cable into the small gap where the belt is here for the X-axis limit switch. This one took some tries to get it connected, and I had to use pliers since my fingers are way too fat to fit. The E cable connects right into the extruder motor right by the rod like this. The other X cable connects under the X-axis motor like this. Now grab the power cable and plug it into the machine with the machine off, and plug the other end into an outlet or power strip. Before turning on, peel the lovely plastic off the screen. This was an ugly peel on my end. My bad. Also peel the lovely plastic off the bed, maybe having to remove the metal clips. This peel was maybe a bit more satisfying. Realign the glass bed if it moved, and attach the clips back. With connection to power, it's time to flip the switch on and power up the machine. Part 10. Controls and bed level. With everything aligned, stable, and built, it's time to finally use the 3D printer. Notice the 4 knobs under the bed. These are to adjust the height of the glass bed. So before doing anything, make sure the bed is lowered by turning the knobs to the right this direction, so the nozzle does not hit the corner. This may happen with the ENDER 3 V2 machine. Also, to move the bed up, turn the knobs to the left in this direction. Now to make all 4 corners lower. With the bed lowered and the machine on, there should be 4 menu options at first. Scroll to the prepare menu and push the knob to select it, and scroll down to auto home and select it so the machine will start homing to 000 or really moving till it hits each limit switch on each axis. Pay close attention and make sure the motors or anything else are not making weird noises and everything moving is really smooth. Hopefully when homing, your nozzle is not pressing into the glass bed, as mine slightly does here. If so, you might have to lower the bed more, or even adjust the Z limit switch up a bit, stopping the machine earlier. With the machine homed, put some filament in and get ready to level, and then finally do a first print. Grab one end of the sample filament and use the side cutters to cut an angle on one end of the filament, as I show here with Matterhacker's build gold PLA filament. See, a nice tip for guidance. Then fit this end through the brass hole here, and the plastic arm should be squeezable so the filament can squeeze between the teeth and this bearing. With a cleaned end cut off, it should fit through and go in the hole to the tubing part. It can be difficult, as I had to fiddle with mine a bit. The best way I found is to disable the stepper motors and use the screwdriver to guide as I push the filament through between the now freely moving teeth and bearing. Also, I put the cables into the little piece here to hold them. With the filament loaded in, all that is left is to level the bed, so the plastic sticks to the bed and the print will, well, print. For the melted filament to stick to the bed, there needs to be a perfect gap between the nozzle and the bed itself. This is a super important step to get right, and will take time and maybe many attempts to even get right. Even I did not get it right the first attempt, as you can see here yourself. The printer needs to be heated first to the temperature for the material, with this case of PLA needing a bed at 60 degrees Celsius and nozzle at 180 to 220 degrees Celsius. So click prepare and scroll to preheat PLA and heat up the bed and nozzle. With the bed heating up, when it hits 60 degrees Celsius, it's time to level the bed to also account for thermal expansion in the glass bed. Scroll through the prepare menu and disable the stepper motors to move the bed and hot end parts. Be very careful as the bed surface is hot. First move the nozzle around the bed, eyeing it to make sure there's a small gap all around. Then go around once more, and in each corner, move the bed up to close the gap between the bed corner and the nozzle. Do this for each corner, leaving a gap big enough to then refine the bed level with the width of a piece of paper. Grab a piece of paper, and starting with the front left corner, I adjust the bed up until I feel the nozzle rubbing the paper. Then I move to another corner and put the paper between them again and slowly adjust until this corner is also rubbing the paper. I continue through each corner, making sure the paper is rubbing in each corner. For a last time, go through each corner again, making the nozzle rub slightly more on the paper. As with the glass bed, I found this gap needs to be pretty tight. I go through all 4 corners once more to make sure the bed is quite level throughout. Do this process until you are satisfied with the distance. If all 4 corners squish the paper enough, try moving the nozzle kit around diagonally through the center to check all of the bed area. If there is not consistent squish, you might have to go through each corner again until there is consistency. You may also have a non-flat bed. If so, contact reality. With that done, it should be nice and level and ready for a first print. Go ahead and auto home the printer and make sure both the bed is heated to about 60 degrees Celsius and hot end is to about 200 degrees Celsius, which is great for PLA. Now, it's time for the first print. Stick the mini SD card into the printer front here, and on the display, go to print and select the file. I first print the cat from the given mini SD card, as this takes about 3 hours and 40 minutes for me. It might differ for you though. Either print will first make a test line on the left as to make sure there is filament pushed to the nozzle and extruding out. Then it will print a skirt or another preparation line around the print. Once the print starts, I look to see where the print is sticking or not, and if it doesn't stick, raise that corner of the bed higher until it starts to stick. This method of live re-leveling the bed during the skirt always works for me and seems pretty foolproof. With my first print failed and then fixed by leveling it during the live skirt, it should be ready for try number 2. I auto home and clean the bed and print the cat again, and wow, look at it go now, perfect bed adhesion, and voila. Through this time lapse, you can see a cat is starting to appear. Very cute. My bed was still warm while trying to pry it off, and I did not want to damage the finished cat print with the metal scraper, so I should have waited for the bed to cool for it to pop off. This cat does use supports, which are the blocky parts, which can be carefully snapped off and scrapped. Please save and look into a way to recycle the PLA scraps. Let's help save the earth. If the print is stuck, you will have to wait for the bed to cool down, and then it should pop right off the glass bed. I did try this one trick I saw by putting some small drops of water around the print, but disclaimer, this may cause stress on the heated glass bed, so be cautious, and also be aware there are electronics, so please do not spill water and fry the electronics. It seemed to help, and the cat popped right off. I heat up the printer again, auto home, and then print the other dog file, which took an hour and 10 minutes for this one. The bed should still be quite level, so this should work just as before, and voila. First the base, and then a tiny little dog is almost appearing out of thin air. With a successful print, I use my scraper to help pry this dog print off the bed and the rest of the scraps. And look at these, both of these prints came out quite beautiful for the very first prints. What an amazing machine. Thank you so much for watching this build and first print guide. I really hope it was clear and concise to help you build a Ender 3 V2 printer. There are a few more videos to come, so if you enjoyed this, you can like and subscribe to look out for new 3D printing content. Thanks so much for watching. Now go out there and print the world.